This is Team Arcoreo, and for this project, we're doing an AEP challenge. We used a temperature and humidity sensor, as well as a phototransistor to measure the temperature, humidity, and the speed of the fan.
Our main goal for this project was to figure out the revolutions per minute of the fan using this phototransistor. To do that, we taped a piece of white paper on one blade, and then using the phototransistor, we calculated how many times per minute that it sensed the white paper.
So as far as the execution of the output goes, the main concern here is to replicate the windmill, and using this PC fan as well as the combination of the phototransistor, and the humidity and temperature sensor, we're able to figure out multiple distinct things. This includes whenever the fan overheats, using the temperature sensor, whenever the fan slows down, using the phototransistor sensor, and whenever the fan will ever have too much moisture buildup, using the humidity sensor. And if we dive deeper into the actual output, as I turn onto the fan, and as I upload the code, I'll see in the serial monitor that it starts off blank to the start, but that's just because the fan is moving at operable speeds. However, if I manually slow down the PC fan, as you'll see in the serial monitor, it'll eventually output hindrance within the fan. So this allows us to figure out these three distinct factors and if there's any problem with our windmill in a realistic simulation.
Okay, so how the code for this works is we have values constantly stored for the rotations per minute and the humidity and temperature. As you can see, the humidity and temperature updates slower than the rotations per minute, and that's because you can only access the humidity and temperature sensor every 2 seconds for it to be accurate. And that's the humidity percentage, the temperature percentage, and these are the rotations per minute that we're getting. So how we're getting the rotations per minute is we're actually using the phototransmitter sensor to check when it's dark and when it's light. So as you can see, there's dips where it's bright right here, and it's usually dark. And every time it's bright, we have a while loop that waits until the end, and then we store that time interval, and then we keep subtracting it from the previous time interval to get the time of a rotation. And then from the time it takes for the fan to rotate once, we can get the rotations per minute.